Hello, I'm Dexter, chairman and founder of Pison. Our company is developing neural interface gesture control for government and consumer electronic markets. Our technology aligns with requirements and adds disruptive capabilities for robots and IoT use cases for human and digital interfaces. Our company vision is to impact the galaxy by delivering the most used and loved neural interface wearables. Let me show you this video of prototyped capabilities for controlling robots, phones, and smart home. Enabling humans to efficiently and naturally interact with robot and IoT systems will be critical to the future success and adoption of these emerging technologies. For example, interacting with a smartphone while on the move, while wearing gloves or protection gear or don causes user error and delays decision and action times. Neural interface gesture control technology allows users to indicate robot waypoints by simply pointing and gesturing where the waypoint is desired or by performing hotkey shortcuts. Our technology today is a wearable sensor designed to capture neuromuscular signals on the surface of the skin, which we then combine with proprietary signal processing and machine learning algorithms. We have 12 patents. Our hardware includes Pison's biopotential voltage sensor, an IMU vibrating motor, and pairs on Bluetooth or on a computer or phone. The output of our SDK is shown in the bottom left corner. Gesture primitives such as lifting up an index finger, thumbs up, and air swipes can be used by developers to map to commands in applications. Gesture control expands the spectrum of when users can interact with robots. As a result, these systems become accessible to 5x to 10x more users throughout the course of a mission, thereby allowing robots to become shared assets and realize their full potential as force multipliers. Pison's technology can be mapped to digital commands that are cumbersome to access on smartphones. Users can access OS level and foreground and background application functions without taking out the phone. As part of the entire user workflow, we have seen 30% faster end-to-end interactions for some of our government customers. Wearable gesture control provides the ability to translate human intent into machine-readable code. Our sensor can be turned on and off with a button press and with a wake word gesture such as rolling your wrist. The user intentionally enters into Pison mode for gesture classifications. 99% of the time, our technology will be in standby mode and not classify hand actions. Pison will be launching our first product this year for key customers, Air Force warfighters called TACPs and CCTs. These users need to indicate on a map program called ATAC where points of interest, navigation waypoints, and threats are located. Drones are used for reconnaissance, though the current methods of interacting with them compromise the user's ability to be heads up and hands free. With Pison, users can arm point in a direction, project a waypoint along that line of bearing, then increment the distance by lifting the finger more times. The action can be done in 2 seconds and save a user from spending minutes of time and significant cognitive load translating the real world 3D perspective to 2D maps. We have demoed to over 200 users and will be fielded to 4,500 users in this customer base in 2024. We received one of the Air Force's top awards for startups called the StratFi contract. The government is leading the way with investments in drone usage as well as augmented reality. Pison is part of that journey and is translating the learnings from users, use cases, and development to other sectors. Pison is collaborating with companies to adapt our technology platform. One of our R&D engagements is with Google to develop smart home interaction of lights and speakers. We are seeking OEM companies who are strategically aligned to the trends in wearable devices and IoT. Likewise, we are interested in turnkey semiconductor partners to design and manufacture a system and package for large-scale production. My contact information is Dexter@Pison.com. Thank you.